Pascal will join me on stage to present only one thing, the Ultrabook.
Maybe not.
Maybe not.
We
need to...
Let me check with how sick is your tablet, you know?
Yeah.
Let me see.
Okay, yeah.
As sick as a...
Yeah.
As a notebook, you know, but this is not just a notebook, you know.
Your book.
This is the next generation of PC. So let me start with some words about an anniversary. You know, anniversary. There is, in 2 weeks' time, there is a great anniversary that changed your life, even when you were not born yet. It means that it's 40 years of microprocessor.
I was born.
Yeah, you were born, so not me.
Really?
So it's now time to do some new revolution with a processor, with a CPU from Intel. First one, I think it's key to understand that with the Pentium, we transform the PC industry and make it multimedia. The second revolution that we created mobility with Centrino technology. So today you cannot imagine that you don't have Wi-Fi or PC. And this is the third revolution. This one is PC is moving from mobility to ultra mobility. Easy to use, always connected.
Yeah.
Ultrabook. Long battery life, and instant on. If you open it, you get automatically a demo running on it. So it's a revolution. Why we can do that? It's because we have the way to control the consumption of energy. Okay, energy is key, and the more you need performance, the more you need energy. And all the work of Intel, each time we are designing a product, we try to provide more performance with less energy. And we have a vision. We have different visions than what we heard. For us, in 2015, there will be 1 billion more users always connected, and about 15 billion devices connected to Intel. And what we mean 15 billion device is, of course, is PC, is tablet, is smartphone, is cars. And I do invite you to go and visit Altron booth, where you have some demonstration on Intel, based on Intel processor. Robots are using more and more CPUs. Gostai and Aldebaran are using Intel CPUs. Why we are able to do that? Because we are providing more performance but less energy and new technology. On top of that, you have set-top box that will also need to consume less energy. So we're into that. Machine to machine, we are talking about grid computing. Grid, it's big data. So how you are making sure that using a grid, we don't use all the grid benefits to be consumed by the compute power. This is on what we're working today.
So yeah, I get you now. Okay, so based on technology, you're telling me that you're putting chips everywhere, but you need to lower consumption, because the more we go mobile, the more we go to this limit, which is, content and device is one thing, but also power. Because if I'm running out of batteries, well, I can't be mobile any longer.
Yes.
So are you telling me that Intel is working on specific devices, I would say, or chips, with very low consumption that would enable us to almost have no consumption at all?
We were talking about dream, you know. But up to now, to give you some example of what we are doing, we have one vision about energy, and the vision is simple. Energy is information, and energy is about human. So about energy is us. So it means I have some examples. So I will start with energy is information. To give you very short example, in 2 years from now, we will launch a new processor, a new generation of processors that we could find in your next PC, next smartphone, next tablet, next car, and it will consume in idle mode 20 times less than what is consumed today in idle mode. This is one example. The other example, energy is information. we know all the challenge that we have in high-performance computing. It means the supercomputer of the planet that are able to calculate whatever you want in meteo or in healthcare or in seismic to find a new way of new power plant and all that kind of things, or on nuclear calculation. And there we are developing new type of processors that you can have up to 50 core on the same platform. So it's what we call many core interconnect mic. And this solution is almost there and will help to reduce the need of power to be able to develop this machine. And just to give you an example that we are about numbers that doesn't mean anything for humans any longer. We are talking today. We are building petaflop machines, and the next challenge is exaflop machines.
Okay.
And to run an exaflop machine today, you need several nuclear plants. But we know that in the future there will be exaflop machines. So between now and exaflop, we have a lot of work to do to reduce consumption. So energy is information, energy is us, and I will ask to run a small video because we developed a solution that is called Poem, that it will totally resonate with what Alan was explaining about positive energy. So Poem, it's a nice name, you know, but it means that each user is consuming energy. And in a building, if you want to move to positive energy building, you need to find ways to involve each human being in a building, in a professional building, to be part of the energy consumption. So Poem is a software that it installed on each PC in the enterprise, and the user will get advice on the machine on how to use the power energy. It can have an impact on the light, on the heat. Also, it can have an impact on reading a document. Reading a document, do I need to print it, or will I read it instead of printing it? As we will see on this small video, and the PC and the software will help the user to make the right decision. So you know, with all this positive energy building, this is a real challenge because we need to be able to adapt the consumption that we will have in the building and the consumption that potentially we want to resell from this positive energy, and we will have to do some trade-off on the way that the people are using energy. So energy is personal, energy is information, and we have to work on both sides to make sure that we are on top of all everyone is doing to try to reduce energy consumption. We need to work together. This has been done with a consortium in France. It's why, even if we are talking English, the video was in French. Okay, yeah, for an American company, okay. You should upload now. Not yet. Not yet. You can wait.
Okay, thank you very much. Well, Pascal, we understand the absolutely challenges. I mean, again, it's back to the human being. So we are the only limits of our technology. Yeah, so as we've seen that in all the other sectors. Okay, thank you very much indeed.
I had one last comment, if you want.
Yeah, sure.
You ask how could it be in 2016?
Oh yeah.
Yes.
That's
of course. So today we need energy to use our nice device. Tomorrow, how could we have a solution to produce energy to use our own device? So we are working on 2 research projects. One is a very nice, interesting one. In this room, there is a lot of energy, not inside you only, but also in the room. And the idea, we have some experience that we are able to charge a PC from the energy that we can capture from any place close to, for example, to a Wi-Fi hotspot. For example, you can capture energy. It's one research way. The second is something that we demonstrated recently at an event. It's called IDF in San Francisco 2 weeks ago. It's what we call Claremont project. Claremont project is you take a CPU like a Pentium CPU for those who know, and you are able to power this CPU just with one photovoltaic cell. So you don't need any longer to look at the plug everywhere. You are producing the energy that you will be consuming with your device.
So back to the question I was asking you. So so you think about producing the own energy to power these mobile devices. Okay. Yes. So great. Well, superb. I'm looking forward to that.
So it's an anniversary, but I don't left you the gift. Okay.
Ah, come on. Yeah, and neither your papers.
That's not mine, but
no, it's not yours. Okay.
Thank you.
Okay, thank you very much, Pascal.